What up, what up? Mr. Perich here. No face in this video. I'm trying something new on my iPad to see if it works, see if it's any better quality, and I don't know. Maybe every now and then I'll just put pictures of my face reacting to things, or I'll figure something out. But today's Back to Basics video is going to be focused on compound inequalities. Compound inequalities. You know what compound means. Compound means two things in one, like a compound word, butterfly. Well, a compound inequality is you have two inequalities essentially taking up one problem, like this guy right there. Now, we have two types of compound inequalities. We have an and we have an or. We're going to start out with doing or. Now, what an or compound inequality means is I give you two situations, one or the other. In this case, we have x is less than 3 or x is greater than or equal to 5. If I order a pizza, right? You guys like pizza, and if the person's like, what topping do you want on it? And I'm like, sausage or pepperoni. If they bring me sausage, hey, that's great. If they bring me pepperoni, hey, that's fine. I'm okay with both. And so both can be represented on a number line, and I'm just fine. Well, that's what an or statement is. An or statement says that I can have both of these guys on the number line. So if I were to graph x is less than 3 in blue, let me get a couple numbers up in here. It looks like I could just start out with 1, 2, 3, 4, 5, 6, 7. So I'm going to put a circle at 3. Don't fill it in because I'm not including it. And I care about all the stuff to the left, so I'm going to fill like a nice big arrow to the left. If I want to do x is greater than or equal to 5, which I'll do in green, I'll go to my 5 right here. I'll put a circle. I'll fill that circle in because I'm including 5. The or equal to includes it. And I want everything greater than 5, so I'm going to go to the right, to the right, to the right. And that's my graph. That's my answer. So what this question is asking is, hey, pick a number that is smaller than 3 or bigger than 5, and including 5. So if I picked, I don't know, 1. Is 1 smaller than 3 or bigger than 5? Yes. What about 12 way over here? Is 12 smaller than 3? Well, no. But is it greater than 5? Yeah. And so since I use the word or, I'm all right to do that. So both graphs in an or statement are going to show up on my number line. Okay? So let's see what we got going on here. Solve and graph m minus 8 is less than negative 7, or negative 2m plus 4 is less than negative 2. So let's do one at a time. Let's do this left one. We get m by itself by adding 8 by adding 8. That crosses out. M is less than negative 7 plus 8, which is 1. Alright, that's the one guy. The other guy is m's not all by itself. I have a negative 2, I have a positive 4. Subtract 4 first. Minus 4, cross u out. That becomes negative 2m is less than negative 6. Right, I'm going to divide both sides by negative 2, divide by negative 2, and oh my goodness, I divided by a negative. Oh, I wish you could see my face. If I divide by a negative, you flip the sign. So negative 6 divided by negative 2 is positive 3. Bada bing. And remember, the thing that binds both of these is the word or in the middle. So my final answer is going to be m is less than 1 or m is greater than 3. That's my final answer. Now I have to graph it. So let me put a bunch of numbers here. Looks like I can do 0, 1, 2, 3, 4, 5, 6. I'll graph the purple one in purple. Put a 0, or a circle rather, at 1. Don't fill it in because it's not equal to. Go to the left of 1, like so. Put a big arrow there, like so. Do the same thing with the green guy. Put a circle there at 3. Don't fill it in. M is greater than 3, so I want all the numbers bigger than 3, like 4, 5, 6, and positive infinity. And that's my answer. Pick a number that's less than 1 or bigger than 3. 0 or a billion. What I can't pick is 2 or 1.5 or 2.5 or 1. Because 1's not included. Alright, let's do it again, I guess. I don't know. Red, we've got 3x minus 1. So let's get rid of the guy floating around first. Let's add 1 to both sides, cross u out. 3x is greater than or equal to 9. Is x all by itself? No. What's in the way? 3. So let's divide everything by 3. Cross u out. X is greater than 3. I did it! I did it. How about dividing... Let's clean that up a bit. How about we divide everything by 4? Divide it by 4. X is now less than 6. So I got a 3 and a 6 there, so let's make a number line. I guess I could start at like 2, 3, 4, 5, 6, 7, 8. And the word that combines these is the word or, so x has got to be bigger than 3 or less than 6. Let me put a circle there. Oh, this is supposed to be greater than or equal to 3. Oh, that could have made a big mistake. Alright, so let's go to 3. Fill it in. X has got to be bigger than that, so I'm going to put a big arrow. I'll go into the right. For the green one, I'm going to go to 6. Don't fill it in, but it's kind of already filled in because that red guy right there is really filling it in. I'm going to the left of 6. Wait a minute. So if I was asked to pick a number bigger than 3 or smaller than 6, well, that's everything. Oh, it's the entire line. I didn't make a mistake. It's the whole thing. Oh. What about 5? Is 5 bigger than 3 or smaller than 6? It's both. Is 10 bigger than 3 or smaller than 6? Yeah, it's bigger than 3. Is negative 10 bigger than 3 or smaller than 6? It's smaller than 6. Any number, any of them, any number works. Oh, hooray. Hooray. Well, that's the yours. Now let's move on to the ands. With an and, both situations must be true. In the pizza situation that I brought up, if I asked for sausage or pepperoni and they brought me sausage, that's fine. If they brought me pepperoni, that's fine. But if I order pizza and I ask sausage and pepperoni, well, I better have both. So this is how it's going to be a little different. I'm going to make my number line 1, 2, 3, 4, 5, 6, 7. And what I'm going to do is I'm going to, for the ands, I'm going to graph these above the number line. So 3 looks like that. Going to the right, I'm going to include 3 because it's greater than or equal to 3. 5, I'll do in blue, is a circle at 5. and x is less than 5, so it looks like that. So with the ands, what I want is the area where both lines overlap. And they overlap in between 3 and 5, but not including 5. So a number that's bigger than or equal to 3, but is also smaller than 5 is like 4. 3.5. And if you're like, but what about 6? 6 is bigger than 3. Yeah, but it's not also and less than 5. So with the ands, I care about things that qualify for both, which means my graph has to reflect that. Yeah? All right. Here we go. Let's add 1. Add 1. 5x is greater than or equal to 10. Okay, divide by 5. Divide by 5. X is greater than or equal to 2. Distributive property 4x. 4 times 1 is 4. That's going to be less than 24. Let's subtract 4. Let's subtract 4. Cross u out. 4x is less than 20. Divide by 4. Divide by 4. And x is less than 5. So what I've got here is my solution is x is greater than or equal to 2. Come on, pen. Come on, pen. I'm counting on you here. X is greater than or equal to 2. And x is less than 5. So let me give myself a little bit more space. If I number these out, what do I have? 2 and 5. I can do 0, 1, 2, 3, 4, 5, 6. I'll put a circle at 2 and including 2. Go to the right. For my green one, I'll put a circle at 5, but not including 5. Go to the left. And my final answer is going to be that spot in between 2 and 5, and I'm allowed to include 2. But I'm not allowed to include 5. So my possible answers for these original inequalities are numbers in between 2 and 5, but not including 5. So 3, 4, 4.9, 2. What are my answers? I'm going to fight you if you don't believe me. No, I won't. I'd never do that. Ugh. Alright, so we've got ourselves a mess of a problem. Let's focus on one thing at a time. Zoom in. I know it's an and. I see that little a over there. That should do it. Alright, we got distributive property. 2 times 4 is 8. 2 times 2x is 4x. Less than or equal to 6 plus 3x. Variables on both sides. I like getting rid of the smaller one, so let's subtract both sides by 3x. Let's subtract both sides by 3x, and 4x minus 3x is just an x. Well, look at that. Bring down the 8 plus, bring down the less than or equal to, bring down the 6. Bring down the house. You don't know what that is. Subtract 8 from both sides, subtract 8 from both sides, cross u out. X is less than or equal to -2. I did it. Well, I did that. Let's go to the other one. Pause if you need to see more. Let's go to the other one. Got 3x plus 5 is greater than 5. Ooh, I see something on the left that's the same as something on the right. I have a feeling that'll disappear. And look at that. I've got a feeling. Oh, I Better stop before I get sued by the Black Eyed Peas. If I subtract 5 from both sides, everything kills each other out, so I'm left with 0. Cero en español. Divide everything by 3. And last time I checked, if I take 0 and divide it by 3, I get 0. So I have my... I tried to squeeze the screen and I made lines instead. Silly me. I've got my 2 guys, or gals, and what combines them, what connects them, is the word and. So I got -2 and 0, so let's make you -4, -3, -2, -1, 0, 1, 2. My and for green is going to be at 2 going to the left. My one for blue is at the 0, don't fill it in, going to the... Wait a gosh darn minute. If this is an and, they're supposed to be the part where both lines overlay, where the green touches the blue. Well, the green doesn't touch a blue. Well, let me think logically here. Let me think of a number that is smaller than -2, but also bigger than 0. Is there a number smaller than -2 and bigger than 0? No, 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 no. So what's my solution? There is no solution. None. So no graph. So a blank graph. We saw a blank graph in my previous video about solving regular old inequalities. Well, it's happened again. Back at it again. There's 2 ways that you can draw an and. Here's the other way. And what basically you're saying here is that -1 is smaller than blah, 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 which is smaller than 4. In other words, -1 is in between blah, 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 and 4. This is an and statement, because -1 is in between blah, 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 and 4. So what I could do is I could split this up into 2 and statements, or I could just solve. And whenever I solve, I do stuff to both sides. But wait a minute. Both sides? There's 3 sides. Ugh. So should I just, if I'm going to get y here all by itself, if I'm going to get y all by itself, should I subtract 9 from all 3 sides? Yup. -9, -9, -9. You become -10. You cross out. Drop down the less than, drop down the y, you become -5. So -10 is less than y, which is less than -5. In other words, y is in between -10 and -5. Y is in between -10 and -5. So let's make a number line that reflects that. Y is in between -10, -9, -8, -7, -6, -5, -4. Y is in between -10. Circle there. Should I fill it in? Nope. Because there's no and equal to or equal to. And -5, should I fill it in? Nope. The symbol here is just a less than symbol, not an or equal to. And y is everything in between -10 and -5. Ah, that's much friendlier. That's much friendlier indeed. I have one more. -36 is in between 3w minus 6. I'm sorry, I should word that as 3w minus 6 is in between -36 and -15. So I'm going to solve by doing stuff to all three sides here. So is 3W, this guy right here, is 3W minus 6 all by itself, or is the W all by itself? No. I'm going to add 6 to both sides. Ooh, I misspoke. All three sides. My face is just like this ink. Red. You can't tell, though. You can't tell at all. Let me see. You become negative 30. Less than 3W. Less than or equal to negative 9. Is W all by itself? No. I'm going to divide everything by 3. Everything. All three sides. And this becomes negative 10 is less than W is less than or equal to negative 3. And I have a feeling I don't have enough numbers to make this a proper number line. Negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4. Nope, just missed it. So I'll go by 2s. I'll do negative 12, negative 10, negative 8, negative 6, negative 4, negative 2, 0. I'm going to put a circle in at negative 10. I'm going to put a circle at negative 3, which is in between negative 2 and negative 4. I'm going to fill that circle in because this guy is a less than or an equal to, and I care about all the stuff in between. So what I'm being asked to do here is look at this original problem, find me W's that if I were to take 3 times that W minus 6, my number is going to be in between negative 36 and negative 15. Well, negative 8, negative 5, negative 6, negative 3. All these numbers in that green shaded area are possible numbers. And that, ladies and jelly spoons, will do it. It'll do it just fine. It was fun. Except my face isn't there. Oh well. I'll just... you'll make do. Although, having said that, I'm pretty sure, knowing myself, I put a video of my face on loop throughout the entire thing here so you wouldn't miss me. Oh, what a narcissist. That's it for me. Bye!